What's poppin', dogs? Mr. Allen here, about to calculate the area of a triangle here, but not any old triangle. We have no right angles, nor do I have an altitude drawn anywhere or anything like that. I just have three known sides. But this little known formula has got your back in a situation like this. It's called Heron's formula. Let me write it down for you guys. The area of a triangle, it's going to look a little crazy, is the square root of S, the semi-perimeter, we'll talk about that in a sec, and then it's S minus A, S minus B, and S minus C. All that multiplied together inside the square root. Well, what are A, B, and C? Those are my sides across from those vertices. The uppercase letters are my angles, whereas the lowercase are my sides. You can see that in any triangle situation. All right, now the S is my semi-perimeter, so what in the heck is that? Well, that is just the perimeter divided by 2. So we'll write S equals, and then it's A plus B plus C all over 2. So you kind of need like two formulas to make this thing work, okay? And not a lot of people know about this formula. I remember learning about it the first time. I'm like, wait, what? Kind of dope. Isn't going to be used all the time, but in the situation where you have three known sides, no right angles, right? This is not a Pythagorean triple. It doesn't fit Pythagorean theorem. This has got your back, all right? So let's go ahead and find our semi-perimeter first. So S is going to equal, let's see here. A is 8, and it really doesn't matter what order I go in here, but I guess I'll just go in that order. 8, 10, and 16. So add those up. Divide by 2. What do we have there? 8 and 16, that's 24, so 34. So 34 over 2, which equals 17. So S is 17. And now I can plug that into this formula. I will go with pink for this one. So I have my area of the triangle equals the square root of all this stuff. So S, which is 17. And then I have 17 minus 8, 17 minus 10, and 17 minus 16. Boom, there we go. Kind of went over some stuff. That's all right. So let's clean it up a little bit here. We got the square root of 17. That's 9. 17 minus 8 is 9. Then we got 7 and 1. Okay. All right, so let's plug that all in the calculator. We got 17 times 9 times 7. 1,071. Okay. So square root of 1,071. Now, hopefully your teacher wouldn't make you break that down, but if they did, there is a little trick right here, guys, and it comes with this number right there, that 9, okay? Both 17 and 7 are prime numbers, so I wouldn't be able to break it down in my factor tree any further than that. But with 9, I've got a pair of 3s, or a 3 can come out because the square root of 9 is 3. So this would end up being 3 square root. What is 17 times 7? I don't want to screw that up. 119. So 119 right here, and that would be feet squared. Final answer right there in my beautiful simplified radical form. But if you want to, maybe have a little more context here, I would just take the square root of 1,071 and get a decimal answer, because it does say round to the nearest hundredth. I just want to show you guys the simplified radical form just in case. So area, final answer. Your area of this triangle is 32.726. So 32.73. Nearest hundredth is dose decimal places. The 2 gets rounded up by that 6, and we have feet squared. So this is the final answer here per the directions of this beautiful problem. So there we go. Heron's formula. It's a two-parter. Area of the triangle and the semi-perimeter are needed for this one. It's a pretty dope formula. There's another one similar to it. It's called Brahmagupta's formula, and it will work for any cyclic quadrilateral. That's a pretty rare one where you got a quadrilateral inscribed in a circle, but that one's got you too. So kind of cool how these formulas work out. Very rare case, but nice to have it in your mathematical back pocket. Anyways, thanks for watching, you guys. If you're still watching, I appreciate it. If you have any questions, pop them in the comments. Otherwise, I hope you keep watching math videos. Have a great day.